In this tutorial, we're going to be working with the variation of pressure with the fluid's depth. Picture, for instance, a tank. Now, this tank is open to air, so we have air. But we as well have, for instance, a fluid. It could be water, for instance. This fluid, the more layers of fluid we have above us or above a certain element, the more pressure it will exert. So if we take, for instance, this element, the more fluid above it, the more it has. Now you can actually figure out that if we define, for instance, this point and this point, both of them will have different amount of pressure, because downwards there are more layers above it than upwards. So this is an element, for instance, of the same water, and a free body diagram of this element, right? If we isolate a free body diagram, it will state that there is going to be a force which comes from the upward part pushing downwards, and this is due to the liquid or fluid that is upwards, but there is also a force that there is going to be downwards due to the same amount of fluid, a little bit more fluid actually, than is upwards. And of course the pressure upwards is lower than the pressure downwards, and this pressure will then exert a force. So since this is a free body diagram, it is very good for us to change this to a force upwards, a force downwards, and of course there is going to be its own weight, right? Because this has a weight, and this will be in equilibrium. So first Newton's law states that the sum of forces has to be equal to 0, and if we state that the downwards, which is positive, minus the upwards force minus its own weight has to be equal to 0, we can overwork, and knowing that pressure equals force over the area, then the force per each element is going to be pressure times area, which means this is going to be the pressure downwards times the transverse area minus the pressure upwards times the transverse area minus, and of course once again knowing that mass is going to be equal to density times volume, this is because density equals mass over volume, then this is going to be density times volume, and volume is going to be a difference of height. So this difference of height of the body times the transverse area, so this is density times the difference of height times transverse area, difference of height times transverse area, and this has times gravity, of course, and this has to be equal to 0. Now, since area is a common term, area can be cancelled, and then of course the difference in pressure between the pressure downwards minus the pressure upwards is going to be equal to the density of the fluid we're working with, gravity times this change in height. And this is very useful expression because it states that a difference in pressure is going to be equal or directly proportional to a difference in height. At the very end, the more deep we are, the more the pressure, and this is because we have more and more layers, and it also depends on the density.